Well, we have another question here, question 5. The question says that the graph of f of x equal to 2 over x plus 1 plus 1 and the parabola G are drawn below. See, the turning point of G lies on the horizontal asymptote of f. The graph of G passes through the origin, and then B is a point on f such that BC is parallel to the y-axis. Now, I'm going to start writing the questions. Okay, let's just read the questions now. Question 5.1, as you can see here, says writes down the domain, the domain of f. So let's first write the question here, 5.1. The domain of f. We're looking for the domain of f, abbreviated like that. Now, the domains are all the acceptable x values, okay? So now when we look at f is the graph of the hyperbola, so this and that, the answer hyperbola are there. So the domain must be on the hyperbola is all the values of x except all the values of x in R except the asymptote, the vertical asymptote. So the domain here will be x element of R, all the values of that, such that x is not equal to -1, because that's the asymptote here. Remember, when you see x plus 1 here, you always must say x minus -1. The -1 is over here. Let me write it like this. We have like 2 over x plus 1 plus 1. This is just 2 over x minus -1. And that -1 here is the vertical asymptote. So the domain is this. So sometimes we can write it like x is element of R, such x is element of R minus this element is -1. Or sometimes someone may write it like x is less than -1 or x is more than -1. All these are different ways of writing the same answer. Okay. So let's move this a little bit. Yeah, there. Oops. Now, the following question is question 5.2. The question says, determine the x-intercept of f. So 5.2, right here, 5.2. We're looking for the x-intercept. Okay, so by definition, or the formula, the x-intercept means that make y equal to 0. Okay, so the f is given by f of x is the same thing as y. Okay, so y equal to 2 over x plus 1 plus 1. Now x-intercept means we're going to make y equal to 0. So this y here will become 0, and then 0 equal to 2 over x plus 1 plus 1. So if I move the 1 over, this will become -1 equal to 2 over x plus 1. Now, when you see a number like 1 like this, it means, excuse me, it was, oh la la, I was writing 1, but instead of writing 4, it's 4 here. So plus 4. So it's 4. 4. Okay. 4. It doesn't affect question 5.1 because it wasn't involved. Even if I wrote 1 here, but it doesn't affect here. So yeah, it's -4. When I move the 4 over, it becomes -4. Now, I was saying negative 4 here has a denominator because all integers has denominator of 1. Okay, now we can apply the cross multiplication technique where I do -4 times x minus 1 and then 1 times 2. So this will become, we can just do it over here. It's become -4 times x plus 1 equal to 2. And then let's expand this. That makes -4x plus, not plus, but minus 4 equal to 2. And then if I move the -4 over, this becomes -4x equal to 2 plus 4. And then, okay, what I did here, I moved this -4 over. And then this will become -4x equal to 6. And that makes x equal to 6 over -4, because I divide both sides here by -4, divide by -4, and now that will make x equal to -3 over 2. That's the value of x. Okay, the x-intercept of f of x. That the x-intercept of f of x. Now, the following question will be question 5.3. This question here. The question says, determine, calculate the value of k. Let's see, k is the x coordinate of b here, every point b. So if I want to find the value of k, what can I do here? We notice that the point b, okay, lies on f of x, on the hyperbola, okay? The hyperbola is here. So now let me just move my board like this, and then I'll do here 5.3. So we're looking for the value of k. Okay, so because k is a point on actually it is the x coordinate of b. B is the the point k 14 over 3. Okay, and then b lies on f, so we can substitute. Okay, we have like f is given by y equal to 2 over x plus 1 plus 4. Now we can sub in the point b in the equation, so this will become what? I sub in y is 4 over 3, and then x is k. So y over 3, 4 over 3 equal to 2 over what? K, x is k plus 1 plus 4. Okay. If I move the 4 over, this will become if I move the 4 over, this will become 4 over 3 minus 4 equal to 2 over k plus 1. Okay, and then we can, I want to have a same denominator here. So if I divide by 3, I must times here by 3 also. So this will become something like excuse me. Oh la la, I missed here. It's 14 over 3, not 4 over 3. 14 over 3. 14 over 3. Okay, yes. So now this will become 14 over 3 minus 12. Okay, it's like 14 over 3 minus 12 over 3 equal to 2 over k plus 1. Now this will make 14. Now that the denominator are common, we have 3 and then 3 there also. We can just subtract the numerator. So 14 minus 12 is just 2. It makes 2 over 3 equal to 2 over k plus 1. Now, here we have this situation where the numerator in the equation are equal. So if the numerator in the equation are equal, then the the denominator must also be equal. In other words, we can say therefore 3 equal to k plus 1. Okay, you can do that. Or you can also cross multiply to solve this. So this means that okay, k plus 1 equals to 3. We can move 1 over, that makes 3 minus 1, and then k equal to 2. Okay, or someone want to cross multiply. Let's just move so that's the answer. K equal to 2. Or if you're unsure, you would like to, you're welcome to cross multiply here. Do the 2 times k, that makes 2 open brackets, k plus 1, okay, and then equal to 3 times 2, which is equal to 6. Now, because you need the value of k, we can divide both sides by 2. You divide by 2 here, you divide by 2 there, and then you end up with x k plus 1 equal to 3. I said divide by 2 over here. And then if you move 1 over, you have like k equals to 3 minus 1, and then it's k equal to 2. The same value of k we got there. Now, you can move, and then see the following equation must be 5.4. Which 5.4 is over here. 5.4 says write down the coordinates of C. Okay. Now the graph is here. The coordinate of C is there. So what? Okay, now move my board. Or before even I do, okay, this simply means that C, the line that we see over here, okay, between B and C, simply tells us that they share the same x coordinate. So the x coordinate of C is also 2. Okay, so its x coordinates 2. Now its y coordinates is like when we sub the value of 2 on the equation of the parabola here. Now we know that its y coordinate is the asymptotes. The asymptotes passes through, okay, touches the point C here, and the asymptote we find earlier. The also the asymptote, did we find it? I guess we did. No, we did not. So yeah, we did not, but the asymptote is you know, this value here 4 is the horizontal asymptote. So the coordinate of C will be 2, 4. Okay, because this value 4, this one, okay, the 4 there is the horizontal asymptote. So C is the point 2, 4. And then the following question is question 5.5. The question says, determine the equation of G in the form y equal to a open bracket x plus b close bracket to the power of 2 plus q. Okay, this is what we call the turning point form of a parabola. Okay, now if I look at the previous question, C, we already find the value of C. They are like 2, the coordinate of C are 2 and 4. So this is the value of P and Q. P is 2, and then Q is 4. Now we need to be careful here. This is where usually students get it wrong. Personally, I don't like to represent these formulas like that. I prefer to represent it like x minus p. Okay, so when you got the value of p, you know that's the value you're gonna substitute there. But never mind, because it will be like, if you see, it will be something like y equal to a open bracket x minus minus p. Something. That's why you got positive there. But anyway, let me not confuse you. Over here, you're going to write y equal to, okay, let me do it over there. question 5.5. So we have given y equal to a open brackets x plus b to the power of 2 plus q. We need to prove to write g in this form. Now we know from this question that p and q are the coordinates of the turning points. Okay, the turning points. Now if I want to draw the same graph over here, let's just keep the graph of yes, here's the graph. Now we did find that c was the coordinate of c was 2 and 4. Okay, so c is the turning point. So c is the turning point 4, actually 2 and 4. Now p is 2, and then q is now you need to be careful when you see a positive number here, you must write x minus 2. Okay, so this will be then let's say y will be equal to a open brackets x minus 2 close bracket to the power of 2 plus q equal to 4. Now it's not just the equation yet because we have the value here of a. So now I must select a point in this graph, okay, to substitute over here. But I can see the graph passes through 0. I need to find a, so I substitute the point 0, 0, I sub in 0 over here for y and 0 for x, and then this will be 0 equal to a open bracket 0 minus 2 to the power of 2 plus 4, and that makes 0 equal to a. That makes what, times 4 plus 4. If you move the 4 over, you have like negative 4 equal to a times 4, and then to find the value of a, you divide both sides by 4 and then by 4, and then you get like negative 1 equal to a. Therefore, then the equation will be like negative open bracket x minus 2 to the power of 2 plus 4. So now that's the value of y. Now, this is really where I wanted you to pay attention, because when you get a positive 2 here, as I said, when you substitute in the standard form, you must put minus 2 there. Just because, remember, 2 here is the value of x, okay? It means, in other words, it's like x is equal to 2. So if you move the 2 on the other side, this is why you get x minus 2. That's the reason why here you get like x minus 2. Okay, so but I prefer to write the same formula like this: y equal to a x minus p to the power of 2 plus q. So if it's positive, I'll write minus minus. Okay, anyway, keep it like that. Thank you. This is 5.5. Now let's see, the next question is question 5.6. Question 5.6. The question says that for which value or values of x will f of x over g of x be lesser than or equal to 0? So let's see. Move my board here like that. Question 5.6. So we're looking for the value or values of x for which f of x over g of x be lesser than or equal to 0. Now, we do know that f of x is what is the parabola that we had. This was 2 over x. What was the parabola again? X. Let's see. So it was x plus 1 plus 4, okay? Okay, let's just see here. Yeah, 2 over x plus 1 plus 4. So this will be, I'll write it here. F of x is, okay, I'll do it this way. F of x is 2 over x plus 1 plus 4. And then g of x, we just did find it early here. It's like x minus 2 to the power of 2, or negative sign is there, plus 4. Okay. Now, we know that this f of x over g of x will be lesser than 0. Lesser than 0 means negative. Okay. Lesser than 0 here will means is negative. If they have like opposite sign, if f of x is positive, g of x must be negative, or if f of x is negative, g of x is positive. Okay, but when they have same signs, they will always be positive. Now let's see which value f of x is negative. Excuse me. It's when it is the same value, the critical values. The critical values is when we're gonna set f of x equal to 0. Now we did it in the previous questions. We can see we did it somewhere here. I remember when we were doing the intercept. Okay, we find yes, when we did make it equal to 0, we got x is equal to -3 over 2. So we already have it right here. Excuse me, here, the critical values. Okay, we have like -3 over 2. Okay, excuse me. Now, another critical value over here then, this is when we have like, we're gonna substitute g of x y by 0 equal to minus x minus 2 to the power of 2 plus 4. So if I move negative x minus 2 to the power of 2 over, that will become positive x minus 2 to the power of 2 equal 4. So if I need to get rid of this power of 2, I can just square root both sides, knowing that this square root will cancel the power of 2, and then we'll have x minus 2 equal to 2, right? Careful, plus minus 2. When you have an equation, always put plus minus in front of the constant. So if I move the 2 over, that makes x is equal to 2 plus minus 2. Now there are two solutions here. There are 2 plus 2 is 4, and then 2 minus 2 is 0. So the critical values are -3 over 2, 0, and then 4. I can write them like that in ascending order. Then let me just show the number line. And then see. I see here. Let's see f of x here, g of x, and then here the fraction. So those are the values of x. I call it number line by mid table. I just changed, I can write in table. Now the values must be in ascending order. Okay, if I write -3 over 2 here, 0 there, and then 4 there. No, I don't need to draw a table. Or maybe I think I didn't want to draw it this way. I did not want to draw it this way. Let me correct this quickly. Instead, I'm gonna do Okay, I'm just going to make a number line, and then, or even a table, I must take in account the intervals. So it's going to be something like this, for instance. If I take -3/2, 0, and then 4. So -3/2, 0, 4. Those are the critical values. Now, if, for instance, I think I have a better idea. Still going to be similar to this. Okay, yes, I prefer to write the numbers like -3/2 here, and then 0 over here, and then 4 over there. Then we can now do this. Yes, like that, like that, like that. Those are the interval. And then extend it a little bit like this. Yes, X is here, and then F, and then G, and then F over G. Okay, now let's work out the signs now. So in this interval between okay, and then less than -3/2, I'm gonna pick up any number here. If I take a number like 2, for instance, a number like -2. I mean, if I take a number like -2, I substitute -2 -2 over here. What should be the answer? So it's gonna be like -2 plus 1 is -1, 2 over -1 is -2, -2 plus 4 is -2. So over here, the interval, in this interval, the answer will be negative, because -2 is negative. Now let me pick up a number in this interval. Negative not there. I'm saying negative actually here for F. For F. Now when I take pick up another number here in this interval, so that's where I wanted to write the negative. If I pick up a number like -1, because between -3/2 and 0, it's -1. Okay, like -1 is in between the two. If I sub -1 over okay, let's do this way. I sub -2 here, we got -2, so this is negative. If I sub -2 over here on G, what we're gonna get, -2 minus 2, whatever here is gonna be positive and negative. So it's gonna be like -2 minus 2 makes -4. -4 to the power of 2 makes 16. So -16 plus 4 is still gonna be negative. Here, still gonna be negative. And then negative over negative makes positive. And then if I take a number like -1 in between -3/2 and 0, I sub -1 there for X. So here it's undefined. Okay, here is undefined. It's undefined. And then if I sub -1 in this equation, so -1 minus 2, that makes -3 to the power of 2 makes -9. -9 plus 4 is negative. So here -1 was undefined. Let's pick up another value. So regardless of the value we're gonna select within this interval, G of X will always be negative. Okay, but let me change the value because we have an undefined value there. I can take a number like -1/2. Okay, -1/2. If I sub -1/2 for over here, -1/2 plus 1 makes 1/2. 2 over 1/2 is 4. 4 plus 4 is positive. So over here, the interval is positive. Okay, now let's move on in this interval between 0 and 4. We can pick up a number. I take a number like 1. If I take a number 1, I know 1 here will make also a positive solution. So it's going to be positive here, positive. And if I sub 1 over here for x, so like 1 minus 2 is -1. -1 to the power of 2 is positive 1, but with the negative here makes -1. -1 plus 4 is positive. So here it's positive. And then positive over positive makes positive. Here positive over negative. Over here positive over negative is negative. And then in this interval, then after 4, okay, we can pick up any value. Let's take a number like 5, for instance. I'll take 5. If we start 5 here, if we start 5 over here, it's still going to be positive, okay? This side will be positive. And then if I sub 5 over here, 5 minus 2 is 3. 3 squared is 9. Minus 9 plus 4 is negative. So we have negative over here. And then positive over negative makes negative. So our solution is we have the critical values -3/2, 0, and 4, okay, because those were the 0 of the function. But is that all the critical values? Careful, there is one more critical value that we didn't mention, okay, because remember the function is also undefined when x is equal to -1. So this was in this case the vertical asymptote. So -1 must also be considered as a critical value. So I prefer to write -1 here because I wanted to write my critical values in ascending order. So we have like -1 here also. Now to find then the interval, okay, over which f of x over g of x is lesser than 0, lesser than or equal to 0, we're going to do that by the help of a table. I'm going to draw my table here, like this, like that. So where are okay, here I'm going to write the x values. Here should be the f of x, and that's g of x, and there f over g. Okay, now let me place in the critical values in ascending order. Okay, this way. If we write -3/2 there, 1 there, -1 there, 0 there, and then 4 there also. So the critical values are like -3/2, -1 there, 0, and then 4. Now let's see. I want to pick up a number in this interval, okay? Before -3/2. I'll pick up a random number. Let's take a number like -2. It has to be the number that I select, the random number that I select has to be in this interval, meaning less than -3/2. Remember, when we are on the left hand side of 0, the bigger this number is, the smaller it is. So -2 is smaller than -3/2. Okay, so if I take a number like -2, I sub -2 over here, we'll have like -2 plus 1 is -1. 2 over -1 is -2 plus 4. It is still positive, okay? So over here, f of x will be positive. Now, if I sub the same value -2 over here in g of x, I sub -2 there. -2 plus -2 makes -4 to the power of 2 is +16, and then with the negative here makes -16 plus 4 is -12, which is negative. Now we have like positive over negative is negative. Now let's move on in this interval between -3/2 and -1. Okay, what we can select a number, pick up a number here in this interval. We can take a number like a number like, I can take a decimal number, it doesn't matter, -1.25, for instance. It is in the interval between -3/2 and -1. So if I sub this number here, I know if you sub here, you're gonna get a positive answer still. Here it's gonna be positive. So here it's gonna be positive. And then if you sub that number here on g of x now, you sub there, after the calculation, you're still gonna get a negative answer. Okay, if you sub 1 point, I meant 1 point, not semicolon here, it's colon. It's colon 1.25. Yes. If you sub there on g of x, you're still gonna get a negative answer. So negative. I think we need to be careful here. Let's correct here. Let's double check. Okay, if you're unsure, let's just correct. It's gonna be like 2 over 1.25. Okay, negative 1.25. I meant negative 1.25. Okay, plus 1. Okay, and then plus 4. What does it make? Oh, it's a negative. Yeah. So this is a negative. Yeah, it's not positive, but it's negative. Negative. Now, and then if you substitute the same value in g of x, you still get a negative, and then negative over negative makes positive. Now let's select also another value between -1 and 0, like -1/2, something like -1/2. -1/2. If you sub -1/2 there, -1/2 plus 1 is +1/2. And then positive plus 4, so gonna be, the answer will be positive here. And then if you sub -1/2 over there on g of x, I mean over here, if you sub -1/2 here, you do the calculation, you're gonna get a negative answer. So you're gonna get a negative answer. And then positive over negative makes negative. Now we move on to the next interval. We can pick up a number between 0 and 4, any number will work. If I take a number like a random number like 1, for instance, if I sub 1 there, 1 is positive, there is still gonna be positive, okay? Because we have everything positive here. We're gonna get a positive answer. If you sub in the calculator, you're gonna get a positive answer. And if I sub 1 over here, I mean, we're gonna get a negative answer. So it's gonna be hold on. If I sub 1, sorry, if I sub 1 here, no, it's gonna be a positive answer because 1 minus 2 makes -1 to the power of 2 makes +1, but it's a negative sign here. Yes, that makes -1 plus 4 positive. So this is also positive, and then positive over positive makes positive. Now over here then, in that interval after 4, if I pick up a number, any random number, like 5 for instance, I take 5, and then for f of x is going to be positive because all of them are positive. So 2 over 5 plus 6, plus 5 plus 1, and then plus 4, it's going to be positive. And then if I sub 4 over here, I mean 5 over here, 5 minus 2 is 3. Okay, 3 to the power of 2 is 9. With the negative there makes -9 plus 4. That's negative. And then positive over negative makes negative. So our solution is where we're looking for the negative solutions here. It's there and there. Therefore, we can say our solution is x is lesser than -3/2. Okay, or x is in between -1. Okay, here it's lesser than or equal, but there it must be strictly lesser than -1 because 1 is the undefined value, so it's not part of the solution. So x there and then lesser than or equal to 0. 0 is one of the critical value, or x is greater than more than or equal to 4. So that's the solution. Using a table. Oops. Okay, that's the solution. Thank you. Here's another question, question 5.7. The last question, let's see. 5.7. Okay. 5.7 here says, use the graph of f and g to determine the number of real roots of 2 over x minus 5 equal to negative open bracket x minus 3 to the power of 2 minus 5. Give reasons for your answer. Well, this is quite interesting question. Well, I want you to, sorry about that. I want you to notice something. 2 over x minus 5 is simply the same graph as the graph of y here, but that's, how can I say, the same graph transformed, okay? Because x plus 1, and then when we see x there, the denominator, it simply means that it is the same graph shifted 1 unit to the right, because it's like x plus 1 minus 1. When we minus 1 here, let me write it like this. Initially, we had like 2 over x plus 1 plus 4, okay? So if minus 1 here, it's going to be, it will become 2 over x, okay? Minus 1 here, the denominator, means the horizontal shift. So the same graph shifted 1 unit to the right, not to the left. Be careful. Okay, when we minus 1 here, it shifts 1 unit to the right. Now, initially we had 4 here, and then we can see negative 5 here. It means we minus this one by 9, and then this minusing by 9 here outside the fraction, okay, means vertical shift. So the graph will be shifted 9 units downwards. That's why this is equal to now 2 over x minus 5. Okay, because the denominator here 1 minus 1 cancel out, and then 4 minus 9 makes negative 5. So the same graph here, the same graph is shifted 1 unit to the right, and then 9 units downwards. Okay. And then negative, we have like negative x minus 3 to the power of 2, okay, minus 5. Similarly, okay, let me write it like this. Initially, we had like x minus 2, okay, to the power of 2, plus, how much we get again there for the parabola? Let's see. It was we got plus 4 x minus negative open bracket x minus 2 to the power of 2 plus 4. Now I'm gonna move this like that. Over here, plus 4. So now this, and as we have like x minus 3 over here, and then in the bracket here x minus 3, and then that there minus 5. Just because we minus 1 unit here, which means shifted 1 unit to the right again. The same graph shifted 1 unit, moved 1 unit to the right, and then over here also to get negative 5, it's 1 we minus 9. So the same shift, the same transformation is applied to both graphs. So this will become negative x minus 3 minus 5 like that. Okay, so the graphs are shifted, both of them are shifted to 1 unit to the right, and then 9 units downwards. Now, let's see. When I look at the y-intercept of the parabola here is what? the y-intercept is when x is equal to 0. So if we sub 0 there for x, you have like 2 plus 4 is 6. Okay, so here it's going to be 6. The point here is 6. Now, if we shift this graph 9 units downwards, so it will be shifted, like you count 9 units downwards. Okay, so all this part we see here will be including this point will be somewhere there. So let's say the intercept will be somewhere over here. So the same graph will be something like this. Okay, and then the parabola also shifted 9 units downwards. Remember, the highest point for the parabola is 4. So if minus 5, meaning it must be like, because here 9 units is going to be like by -3 there. And then if I do minus 5 must be somewhere like, so -4 and -5. Okay, so the parabola will be something like this. That. Now you notice with the parabola will not even cross the x-axis, but the hyperbola, this arm of the hyperbola, this arm, because this one also shifted 9 units, it will be somewhere there, something like that. Okay, and then you see that there will be only one real root on the two graphs here will form only one real root. So the answer is one real root. Thank you.